Oh, so we just got to click on that. Perfect. Okay. All right. So what I wanted to talk about today was a topic I've spent a little bit of time talking about other places, but I'll try to tune it to what I think are some of the more salient points for this group. And it's around this idea of data science and what are we building these days in this whole realm of this thing called data science. I think it's important to first start with why does data matter? I mean, we know it's a chaotic world, and we always know that it's really the only way to survive in a chaotic world is with data. But before I get on with that, I thought because it's an afternoon and it's kind of late in the day, I thought we'd start with going back to something really simple and trying to emphasize what does it mean to operate in a chaotic world, and what does it really mean to have data and really try to operate. So I brought with me a science experiment, and this is not it, because it's really best that you keep a data science wrapped up in a pink towel. So here it is. It's something very, very simple. It is two pendulums connected to each other. So nothing special except that they can bend and move in all sorts of crazy ways. So something super simple. And so this, in fact, is one of the first devices used to actually prove something called chaos theory from the labs at University of Maryland. So I thought we'd kind of see what fun lesson we might be able to learn from this without destroying our host's furniture. So let's do this. Okay, so first thing we have to do is we need to practice to learn something from this experiment. And so here's how we're going to do it. So everyone, raise your right hand. Okay. You're not raising your hand. There you go. All right. Everyone's got the right. Some of them need the other right. We're good. Okay, so raise your left hand. Okay, here we're going to practice together. Let's try that again. Oh, come on, guys. All right, there we go. Okay, here's what you're going to do. That is exactly the thing that you are going to have to practice with. Your job here is to predict when the last time this blue piece is going to go through this upper piece. So if you clap and then it goes through again, you lose. No one likes to be a loser. So you want to be the first person to clap when this goes through. So if it goes through here, someone else claps, and then never goes through again, you also lose. Don't be a loser. Try to win. Okay, so now this is a little tricky. So you're going to get 2 claps. Got it? You want to be the last time, pick when the last time this is going to go through, but you want to be the first person of that. All right, if you can't see, you're going to have to move because it's going to get a little dangerous. We're not going for the trivial solution. Some math guy out there was clapping, right? All right, here we go. Ready? Now I can see who the type A people are. They're like... All right, here we go. Whoa. That's why you get 2 claps. Little too type A. Think about what's going on for a moment. Why are you so bad at this? So far, you guys suck at this. Why? It's such a simple thing. You know, everything about this is 4 variables. It's all it takes to predict this system. The position of the blue piece, the position of the upper piece, and the angular velocity of the 2. In fact, it's a very simple physics homework exercise to write down the equations for this. When was the last time you saw a spreadsheet with only 4 variables? Yeah, here we are talking about big data. Oh, that's pretty good. I think some people had to use 3 or 4. They're on the 4th claps. So this time I want you to think about something slightly different this time. All right? We're going to do it again. I just want you to get a sense for how different and how complex the behavior is. Remember, everything about this is only 4 variables, 2 positions, 2 angular velocities. But why such complexity? Why so hard? And why is that kind of moment you go, what just happened? Because remember, we are all data products. Every one of us is a data product. We're taking in observations, we're seeing lots of stuff, and yet our brain processes it, and then the predictions break down. So we are not very good data products for this. So what can we learn from that? What does that tell us? Like all of a sudden here, it looks really simple. Very different behavior this time than the last time. Right? So there's really 2 lessons. Thank you. Yes. So there's 2 simple lessons to take away from this. If you want to use data to control a chaotic environment, control a very complex system, how do you start to think about it? There's really 2 things that you need to take away. One is you have to have lots and lots of high-speed observations. You have to have really good measurements. And 2 is there can't be any latency. It's got to be fast action. Now, how do you think about that? Why is that true? Because you can actually design a control system that's going to balance this, but it's going to have both of these. How do you think about that? Well, you ever try to balance a broomstick on your hand? You ever try to do that? All right, you ever try to do it drunk? All right, homework. All right, so what happens? You're slow. You don't have good observations, right? You don't actually get able to process as quickly. That latency, so very quickly you start doing these wild behaviors. So that's one side of it. The second, what about if you have limited observations? Try to balance a broomstick in a dark room? Not going to happen, right? Now think of it as say, okay, what if you had observations once every second? You could do that by doing a strobe flashlight. It'd be equally difficult. So you need to have high observations saying, and this is just a simple way to start thinking about how complex data is and what it can do for us inside a chaotic environment. And it's also a nice way to keep as a reminder to us that even though we're working with big data, sometimes really simple systems can be extraordinarily complex. And so how do we start thinking about that with respect to this area of data science? And so I think that one of the things to start thinking about in here is, as we understand it, is what is data science? What do we think of that as? And one of the ways I like to think about it is much more so about what a data science organization does. What is a data-driven organization does? And for me, the definition is an organization that it acquires data. It brings in high-speed, high-timely data quickly. It leverages that data in a timely fashion to basically create efficiencies, navigate the competitive landscape, control. You're using that data to control the environment, to be able to balance. So, first thing that we do I think it's important for us to take a step back and realize that we are entering this new world. I like to take the big out of data. I think we've all been doing data for a long time. We don't have to get caught up with the term big. But what's more important is we think about it is the ease at which we can do data now. And one of the ways to think about this is through this graph. How many of you guys know that is Kirk? All right, how many know this is a Priceline guy? Now we know the generational split here. So I'm with Kirk. Now here's one of the things. This guy did this cool thing of said, well, I'm just going to figure out how many Google searches there are with the number of letter of A's in there for Khan, from that famous scene of Khan, right? And one of the things that you start saying here, you're like, there is somebody out here near 81 that has near 100 search results. Think about that, 81, like you had to fall asleep at your keyboard to get 81 A's. I mean, it's not trivial. Yet there's 100 of those, so an interesting insight. But here's the point. Think about this 15 years ago if you wanted to do this. What would it take? You got to go buy a piece of hardware. You got to figure out where to plug it in. You got to go get the connection. Finally, you go build a scraper out there. Then you got to get some ETL process. Then you got to go buy a database. Jeez, that's a lot of requisitions to make inside a company, right? And now instead, what do? Spin up an EC2 instance, get your calls deployed, throw up Mongo or whatever your favorite database is, MySQL, whatever, and you'll send you off and running. This has gone from a process to an interview question. And that's part of the thing, is that we can do that data really, really simply, efficiently these days. And so it's not necessarily so much about big as the speed and effectivity that we can do this at. So next on, let's talk a little bit about some of the functional areas of data science. I think it's important that we start thinking about the functional areas rather than just how do you structure the team. And the reason for this is I think what we're seeing as we get this ease of using data is that there's many different places or areas we can start to use data science in. And the first of that is decision sciences and business intelligence. I believe decision sciences is the next version of BI. BI used to be that traditional thing where it's kind of like, hey, create some reports, create lots of dashboards, do that stuff. Decision sciences, this is the guys that BI is supposed to be. You get to a business fork in the road, you go left or right. That's what the decision sciences guys do. They are the understand the user, the usage, the yes, also reports, dashboards, all this stuff, the special analysis, the A/B testing, all of these things. And I think the best decision scientist out there is this guy. What does Kirk do every time there's a decision that has to be made on the bridge? What do you think, Spock? He doesn't do what we do in every corporation, which is go down the turbo lift, go down the hallway, go down all the way back to some dark room where there's a bunch of guys at computers say, could you pull some data? And they say, well, I don't understand. Why are you pulling this data about the Klingons? I have no context. This guy is on the bridge. He's in the decision-making, next to the decision-making chair every single moment. He's got context. So when he says, like, ask a question, he's able to think about all the other relevant aspects. That's what decision science is. It's from moving from the back shop all the way to the front shop. And usually the data scientists, think about for those times where you're in the room and somebody asks you to get some data and you're like, I have no idea why you're asking me for this, but fine, I'll get you the data, I'll do that poll. And then they come back and they're like, that's not the data we wanted. And you're like, no bleep, Sherlock, because you didn't tell me that you were trying to do this, and I would have given you different data, right? That's why it's so important that it's decision sciences. There also needs to be a zero overhead rule inside organizations with decision sciences. We put these tools out there, and oftentimes, first thing you do is say, you got to go to training. That's ridiculous. We're making the tools too difficult, especially in a model where we're trying to get more and more people inside your organizations using data every day. So what is an alternative to this? When was the last time you had to go to training class for a Zynga game? When you go to LinkedIn, do you really buy the Dummies book? Right? Does Facebook, you're like, oh crap, a new version of things come out. I'm going to only use Facebook once the manual comes out. Right? No, because these products are designed to create a glide path to help you understand it. There is no reason we shouldn't be developing enterprise products in a way that makes it as easy to use as a social system, as a LinkedIn, as a Facebook, as a Twitter, as a Zynga, all these things. So creating a zero overhead rule for the tools that are both created by your teams internally, by the dashboards that are created, all of that. Because how many times you go in there and you look at your dashboard and you're like, I don't understand what that number is. And then you realize like nobody else around the table really understands what that number is. Right? Some people are laughing. They're like, oh, that was this morning. Right? That happens all the time. But why isn't there like a hover or something nice? And part of the reason for that is because dashboards are products. That's simple. If you take that approach of a dashboard as a product, you don't want a crappy product out there. Make your dashboards nice. It's pretty well known that if you make your dashboard look nice, the right type of thickness of the lines, the right type of shadows, people will look at your dashboards longer. People will care. Same way, how do you interpret the data? Make it easy. Make it a product. The next area, fraud, abuse, risk, and security. The guys that find the bad guys, right? Finding bad guys. That's a signal noise problem. The bad guys are always trying to evolve, sneak under things. Use data scientists. LinkedIn, the fraud team that we created comes out of data science. They're all data scientists. Now, they come from all different walks of life, but they're all data scientists. Give you an example. Here's my LinkedIn graph. Over here in orange are LinkedIn people. Up there in blue, there's two types of blue, different parts of Silicon Valley. Green down here, over here is eBay, PayPal, and Skype. That red in the middle, that's an emerging new cluster of data scientists. That wasn't there a couple years ago. Up into my upper right, your upper left, those are different places for my government time and time at the university. Notice one thing about this. It looks really, really messy. It's not clean, right? I guarantee you that is nearly impossible to fake. So what you do is, if you have a bunch of data scientists and you said, hey, we want to find fraudulent networks in finance, in national security, in social network systems, and you just look at the networks, and I showed you, this is a bad network, this is a good network, and I showed you 10, 15 of those, with better than 70% accuracy going forward, you would be able to tell if that was good or bad. Forever on out. With a little bit of training, a little ML, a little extra parsing, you'd get to over 90% very quickly. Why? Because it's a data science problem. And we've taken a fraud problem and made it a data problem. And that's just an example of one. Next, data infrastructure. You know, somebody pointed out to me, we used to call things data services. And they said, that seems like a wrong term. Why are we just serving the data? Why aren't we innovating on top of this? And I said, that's a great point. It should really be data infrastructure, data operations, data engineering. It's not just services. Because if we're going to move everything to the front end of the shop, these guys have to own all the stuff as well. And so in this, these are the guys that own the data warehouse, but they also build tooling. They're really focused on tooling, on how to move the data around, how to make it easy, accessible, all those different aspects. And a critical component of this is the emphasis on tooling. Most of the organizations that I see don't continuously invest in tooling. So that prevents the ability to create efficiencies. And what is that? Some examples of that really gets down to this question around what I call the toolbox model. How many times you go and you're having a conversation and somebody says, well, which system are you going to pick? You're like, why would I pick one system? And they're like, well, you only get to have one choice. You get to have Oracle or Aster or Greenplum or Hadoop. Which one are you going to pick? And they say, well, it's cost too much. You're doing this thing. To me, that's the same question of like the sink is leaking at the middle of the night because you only get called for data problems when things go wrong inside a company. Right? But the sink is leaking, and you call the plumber, and he says, which tool do you want me to bring over? You get one. Makes no sense, right? The same way in companies and organizations have to get comfortable with knowing that different tools are used for different things. That seems simple, but oftentimes, especially at the CIO level, that gets very challenging. I'll give you an example. These are just some of the tools that are used at LinkedIn. Aster, Hadoop, MicroStrategy, Processing, Prefuse, Oracle, MySQL, Voldemort, a lot of stuff that's been invented. Now, why does stuff get invented? One of the reasons that so much stuff is invented at places like LinkedIn, Facebook, Twitter is because there's a constant and consistent emphasis on creating efficiency at the data layer, tooling. For example, Azkaban, which is a scheduler. LinkedIn invented something called People We Know, and it quickly took off like wildfire across the internet. You saw it quickly appear on sites like Facebook, High Five, Orkut, you name it, all over the place. LinkedIn was fairly slow to productionalizing this, making it run very consistently over time. We started on Greenplum, then we moved it to Aster, and finally to Hadoop. In that process, one of the things that took place is we realized these jobs would fail very regularly. And so what we do, you get paged at night, and then you have to wake up and you just literally hit return. That's an awesome use of your REM sleep cycles. So what happens after a while? It's like, well, maybe we should build something so we don't have to do that. Maybe it should have restart on the job. Maybe it should have all that stuff. And so what you build is a scheduler system. It's oddly enough looks like one of the classic PDP style schedulers, but you're building tooling to make yourself efficient. So now, forever on, you never have to get paged to be woken up at night for that. And yet, you've also built a new technology that you can use in a lot of other places. So tooling, creating efficiencies is critical in this area and environment. The next area, product marketing and sales analytics. I think this is the next tier where we're seeing a lot of efficiencies and people creating new stuff. And the reason for it is because this is customer and user facing. And an example of this, it starts, as I mentioned, with People We May Know. This example, just to highlight, is a great case because this became an entire meme across the internet by one data scientist, Jonathan Goldman. He had this idea, and it's real simple. When you got here in the morning and you were milling around, what's the first thing you did? Did you do the counterclockwise walk? You do the clockwise walk, see who you know, and finally you know somebody, and you're like, oh, great. You go get the coffee and kind of pretend to huddle until you see somebody you know, right? We're all used to doing these things in physical environments. But now think about that when you go to an online system like a LinkedIn or a Facebook for the very first time, you don't know if anybody's there. It's the same feeling, like you've got to walk around this physical environment before you get comfortable. You don't even know your friends are here. And the only things you can do is address book import, which you may not be always comfortable with, or search when you don't know who somebody to search for is. In this case, what Jonathan realized, he said, hey, you know what? We should tell you exactly who these people are. So what he did is he just wrote a quick heuristic script, the same one you use at any time you go to a birthday party or you go out and you're stuck next to people you don't know on the plane. What do you do? What do you do for a living? Where do you work? Where do you go to school? Great. Now you guys all know people we may know. That's all there is to it, right? Triangle closing. Lennon and I know each other. Scott knows Lennon. I should probably know Scott. Just triangle closing. Those simple things. But what Jonathan did is he took over the ad slot on LinkedIn's homepage and just put this in there and created a unique ad for every person. And then said, hey, here it is. And it had incredible high click-through rate. Because what he realized is it's the same problem as a physical environment. And one of the important things with that is there's two differences on the online representation of this. The first, if you're online, it's like that you're walking into the conference area for the first time, except the lights are off. You can't see who's across there. There's nobody there. The second is you can teleport away instantly because you just close the browser. And so one of the things that's here is we've taken data from a back-end process and a back-end shop and moved it all the way to the front end as a product. We're seeing more examples of this. This is one of my favorites. It's from a blog called OkCupid. Anyone use OkCupid here? You don't have to admit to it. But it's a dating site. And it's a dating site. You're not trying to find your future match all the way, although my cousin found his wife on there, or my wife, future in-law found him that way. And what you do there is you're trying to do matching. And so you enter some early questions. And as you enter questions, they realize that you could find all sorts of clever stuff. And they put out these things here. So this one was on the mathematics of beauty. And what they did is they realized that the photos that are uploaded have all sorts of metadata, such as the time when they're taken, some cases, all the information about the f-stop or the type of camera. And so they had a few results that they looked. And they said, the more men as a group disagree about a woman's looks, the more they end up liking her. Okay? Guys tend to ignore girls who are merely cute. And the fact having some men think she's ugly actually works in a woman's favor. So interesting stuff. They do this stuff. Now, some of they get even more edgy. For example, what they realize is a lot of times when you use a site, you're using from a device. Well, they found out, they came out with a blog post that said, hey, Apple or iOS users have sex more often than RIM users or RIM or Android or Microsoft users who probably weren't on the system at that time. But, but the fact that they do this, one of the things that's interesting is their edginess of this creates a massive following and it creates incredible media buzz. If you're a new system, and they won't let me tell you how many numbers they get of users after they post one of these things, but I guarantee you if you were a new startup, you would love to have numbers of users like that. It creates an incredible bump. Why? Because this gets you on the morning, gets you on every talk show. This gets you on Jon Stewart. People know about your brand. And because they're not trying to be the eHarmony, they're trying to be that more edgy, it plays into their favor. This is an example we did for the Wall Street Journal. This gets you on the homepage of the Wall Street Journal. What's more interesting? Job titles. How are they going? The hot job titles. So we did this. Monica Rogati did this and said the growth of ninjas. That's what ninjas are like. Well, what's it like if you're a guru? Not so hot. Evangelist, still okay. This gets you the homepage of the Wall Street Journal, right? Marketing can't buy that. Putting something like the 10 most overused buzzwords on LinkedIn, that gets you on USA Today. That gets you the front page of USA Today, right? Good Morning America, those different things. So all of a sudden you're taking your data and you're using it as an advantage for marketing purposes, as well as product purposes to explain your value proposition. And we're seeing much more of that. Similarly, in the case of Amazon, people have seen that, people who viewed this also viewed this, people who viewed this, people who viewed this, bought this, people who bought this, viewed this and this. You get all the variations. Same exact model. Think of it, what happens if you go into Best Buy, you go into Fry's down the street and you pick up a pair of headphones. What's the first thing that you do? You pick it off the shelf, you look at turnover, you look at some details of it. What exactly is there on the Amazon page, the reviews, some information about it. But then what do? You look to the left, you look to the right, you look up, you look down. You look at all the other choices around you. Online, there isn't an easy way to do that. So what do? You mimic that through a data process, through the collaborative filter. That's exactly what people who viewed this also thing is. It is being able to replicate what you see in real life online, and the best way to do that, one of the best ways to do that is through data. Here's an example. This was put together, an email. People may have gotten this. It said, DJ, 2010 was a year of change. 363 of your LinkedIn connections started something new. Here's a few of them, and it shows you lots of pictures. This email gets more click-through than any other type of email out there. Why? It's got pictures. It's making you feel like, oh my gosh, Patrick's got a new job? How did Patrick get a new job? That's ridiculous, right? Nathan, oh my gosh, this is my best friend. I'm such a bad friend. Ellen, wow, okay, I got to know where she is. It's getting clicks. This email, total time to delivery, less than 1 month. Really, total development time, about a week. Why? Because you had an incredibly creative guy like a guy named Joe Adler who says, hey, you know what? I can build a system that takes my Hadoop data, plugs it all together, and creates this nice thing, and a really creative designer that says, hey, here's a creative way to put it together. All of a sudden, you're out there testing, and it goes massive impact. So you're taking data. This is a data product. Whoop. One of the complexities here of making data is also that data can kick you in the ass, especially as you're building a product. This is an example one called Career Explorer. It tells you where you can be in 5 years, 10 years, 15 years as a student. Guess where you are going to be in 5 years? The same place you are today. You're not going to change jobs. That's not very interesting. It's actually a pretty crappy product, right? So how do you balance that? You say, oh, wait, we should try to build a product so it plays the edges. So now all of a sudden you say, hey, you know what? You went off to be a veterinarian and then you became a mountain goat or sheep herder, right? Something crazy. And people go, what? That's a terrible result, even though there may be a few people that do it, right? And so part of that is knowing how to make data look like a good product. How do you make it do it? Especially if you're bringing in disparate data elements. Think Cobalt. Cobalt, if you're going to say you're going to go want to learn about Cobalt, is it Cobalt the language? Is it Cobalt the metal? Right? So if you're pulling salary data from another source and blending this in, where's it coming from? Because part of it's going to might be from the wrong source. So you got to sort all those things out. And traditional QA processes are not equipped to do this at this time. Let me just talk a little bit about building the team. What does it take to build data scientists? Well, first you got to know how hard it is to hire. Here's what this is from LinkedIn data from 1970s to 2005. That's the demand curve of data scientists or people in the analytics space. So it's kind of grown. Guess what it looks like today? That's that jump. And that's growing even more. It's one of the most hot in demand fields. So what are you going to do about it? The number one thing that you have to do and treat for all data scientists is the following. There's one common complaint, and you have to alleviate this complaint. Be in control of their destiny. Have you ever had an idea? They're either in data and gone to the product manager or the GM and say, I've got this idea. What do they say? Like, that's nice. Nice little data person. Go back to your terminal. Maybe next time. Right? No data products get built. Great example of this, Yahoo. They have amazing, amazing ideas, and yet they never were able to get them in production. Why? Because they weren't in control of their destiny. You talk to Google people in R&D, they have the same problem. You talk to people in Microsoft, the same problem. People at any lab, it's the same thing. They're not in control of destiny. They can't make this stuff real. So one of the things we did at LinkedIn is we said, let's make it a top-level team. Let's make it one of the top, be in control. So if you want to make people you know and you want to put it on the homepage, you go do it. Also, you're also responsible in the same way like all other product teams, that if you screw up, you're also penalized the same way. So all that, just like with control of being your destiny, you're also responsible and accountable. So once you get that solved as an organizational level, what's a do-it-yourself guide? Well, the first thing is to where to look for data scientists. And the first thing is look for intense curiosity. They got to have a passion, absolute innate passion for playing with the data. And they have to have a historical trend of being able to use data, manipulate the data to solve a problem. They really got to work on top of the data. All the top data scientists I know just have always played with data or had a really, they really get in the nitty-gritty of it. What are the key skills? Being able to find rich data sources, good data sources. Many times the data sources that people pick aren't very good. Working with large volumes of data despite hardware, software, and bandwidth constraints. They don't care about the barriers. They break through them. They do whatever they need to. Cleaning the data, making sure that it's consistent. Melding multiple data sets together. Taking those data sets, bringing them together so they can be used. Visualization of data. Being able to tell a story. They have to be able to tell a story with the data. And that is because we are all visual creatures. So it has to be explained through visualization. It's not a paragraph. When's the last time you actually read a paragraph, right? USA Today figured this out. If you write a paragraph, no one reads it. If you make an infographic, everyone reads it, right? It's not to say necessarily do everything with an infographic, but know how to tell a story with your data. Building rich tooling, because you got to make your life easier over time. Where should you look for them? Most organizations already have them. Almost always when I visit an organization, they'll say, we need to find data scientists. Like, the guys I had lunch with sound like data scientists. You're just not letting them be data scientists. So people are often locked up. They're artificial constraints. Interns are one of the best ways to get data scientists in your organization. Get them in because they don't know any better. They're going to go break all the rules. And so they oftentimes they go through and they're a bull in a china shop and they make data happen because they don't know better. And using that and emphasizing to them that power gets you a long way there. Look in fields where people aren't aware that their skills translate. Jonathan was a physicist working on condensed matter. I was a mathematician working on trying to understand this. Right? People often use these skills in different areas. They're applicable. Build strong relationships with your academic counterparts. Great feeding grounds. Principles for talent. I'll just talk to this real quick. I've written a bunch about this. There at LinkedIn at Analytics, we had 3 primary criteria for anybody that joined the team. The first of which was a flippant way of saying that we want to spend a lot of time together and we expect no-look passes. And the way we said that was, would we be willing to do a startup with you? Why? Because we need to have trust, the time we're going to spend, and that communication. Those are the 3 principles of why. That was the first thing. And so every time we get in the hiring meeting, these are the questions that we'd ask. The next is, can you knock the socks off of the organization in 90 days? It's a handshake for we're going to onboard you quickly. 2, prove what you've got. I can't tell you the type of impact it has when you go into one of these kind of larger meetings in a company and everyone's like, who's the new guy? And no one takes them seriously, but then they're like, oh, that's the guy that did that. Holy crap. It changes the whole tone of the conversation. It changes the way everyone interacts. And so knocking the socks of the organization in 90 days also gives people flexibility to try new things. Some of LinkedIn's biggest products were all created in the first 90 days of people's time. Career Explorer by Chris Riccomini. A lot of those data blogs that you see are 90-day projects. Skills Project by Pete Skomarok. All these different ideas, 90-day projects. And a lot of the internal tools. A lot of the internal tools that make people's life easier was done there too. Third, will you be doing something amazing? We want to recreate the PayPal Mafia model for LinkedIn. I believe absolutely there's going to be a LinkedIn Mafia. And the expectation is that people will be doing something amazing in 4 to 6 years. What's amazing? The next LinkedIn, the next YouTube, the next Palantir, the next Tesla. That's what we define as amazing. Maybe amazing in the company. You may be running the company. Awesome. But that's what we expect. The reason that's important is that's a handshake that says, we expect you to make the company amazing because once the company's amazing, you have an amazingly high, we're all into the amazing word, a very high jumping off point to go jump into whatever you are. That's why we do it. So that's a way of really retaining and how we think about talent inside the data science teams. Organizational lessons learned. Some of the lessons that I've seen over the years working with data science teams. First, people that work together need to be close together. Data is an incredibly brittle process. and you need to have everyone closely tight-knit together, because otherwise somebody's working over something and you just realize that a flag was incorrect in a query or something was weird. Get people close together if they're working on data. Next, train people to fish. Democratization of data. Get all this pulling data off people's back. Get other people to do it. Get everyone to be in power so they can get their own data. It creates an incredible amount of efficiency. All the functional areas must be in contact with each other. QA, all these things, it's really critical. Third, invest in your people, the process, the tooling, and the infrastructure, and you have to emphasize again, infrastructure. It's so critical to have that great infrastructure. And I'm going to wrap up there. If there's any questions, I'll take them now. Thank you. Or we can get drinks. Yep.
How important is deep flight statistics knowledge to be a data scientist? I mean, that's an integral part of it.
How much is the, if I heard you correctly, how much is the integral notion of statistics to being a data scientist? I think statistics is an integral part of being an adult. And unfortunately, that is missing in a large part of the adult population. What I think, though, in the data science as a community, we're over-dialing to statistics in the knowledge that people need. You know, oftentimes we get so focused on what's the significance of something or what's the t-test criteria, and we get it in a way that is the problems that we look for are do not necessarily need advanced statistics. You know, there were, Ron Kohavi spoke here 2 years ago, and he explained all the ways A/B tests go wrong. And I think it's a great highlight to the ways that statistics can go wrong and confuse you. In fact, most of the places I find that when you're doing a test or an experiment on a system, the good answer often is obvious. And if it's not obvious over the other ones, then something very likely has gone wrong. So, for example, many times you'll see it do a test and you go, wow, that one blew out all the other results. Let's clearly go that. We don't need a heavy statistics test. As you get into big systems where you're micro-implementing, like at the size of a Google or Microsoft or an eBay, yes, the statistics becomes very important. But it also becomes very specialized at that point. But for the early part, what I actually like to see is, more importantly, is how do you work with data? How do you, like, what's the first thing you do with the data? Is it, do you look at the data? Do you do distribution of the data? What are the different tricks or techniques you do? And statistics is one of many toolboxes that are out there that help you do that. The same way with ML or other things. People have these base level skills that get them to have an understanding of the data. I think data oftentimes is you walk into a room dark and then you're trying to figure out what's inside this room. And statistics is one of the ways of feeling it out. Mm-hmm. Yeah, Lynn.
So what you've done at LinkedIn, pretty much you have a lot of support from Reed and everybody in terms of what you've done.
Yeah.
So what you've accomplished at LinkedIn and the whole data science team and in general the organization evolved in the past few years. When you take something like that to an enterprise and where is already some existing protocols, processes, and legacy and other things, how would you approach?
Yeah, so one of the things, LinkedIn originally when we first started building a real data science team was about as far from data-driven as you could get. And people find that hard to believe. People didn't understand very basic things. So one of the first things that we did was we took a week and we created every single graph we could. Every single graph we could think of. Things such as, okay, there's this many users that showed up this week to the site. What would it look like if they showed up the next week or the following week? And you can do those kind of cohorts. And we just cut that data and did every single thing we could, and we invited the entire company to come and comment on it and just talk through different aspects. And then we created graph after graph after graph, and we created something that was called the State of the Union. And this became the kind of the Bible that everyone started to use to get an understanding of what's going on in the system. Similarly, we did things at eBay that way when I was there, or in the national security. And I think one of the biggest things that you're looking for when you walk into an organization that has a lot of tradition, or it's been moving a certain way, particularly that hasn't been data-driven, is that you have to present a story and a case of why data is valuable and what it can actually do. And the best way to do that is, I think, the 90-day rule. And what is it? What is the innovation that can actually take place? You know, even at LinkedIn, well, we used to have these hack days, which are really a fantastic way to do it. We call them in days. And what happens, in days are one Friday every month, and you're allowed to work on whatever you like. It's LinkedIn's version of a 20% time. And what happened at that is everyone that was winning was the analytics team. Why? Because some of the coolest stuff you can do is with data. I'm not biased or anything, but the point is what happened after that is all the teams. You'd have even the sales. There's a guy on the sales team that was hacking on top of data because he was like, this is so cool. And so then all of a sudden, everyone is getting in the mind shift of doing that. And it takes a little bit of time. Now, of course, we stacked the deck so that we knew everyone was going to, like, analytics would always win. And the way we did that was we secretly allocated a little more time for ourselves, so we cheated. But we're also trying to drive culture change through innovation. And I think that's one of the things is once people get a sense of like, oh, that's what we can do, then it's a question of what's the right, well, I talked about the functional roles, what is the right organizational structure? And that's specific for each company. Yeah, or wherever you can run to easiest. How about that?
I won. Among big data startups, what are the areas that you're seeing the greatest innovation today?
The greatest